Hello, welcome back. I'm going to solve a numerical example. We look back at our mechanical system that had spring, dashboard, and mass with force of F constant for the spring K and C for dashboard. We are going to work based on some assumptions. So the basic assumptions are that at very start, when there is no force, the movements or displacements are zero. So that means that x of 0 is equal to 0. Another assumption is that at the very start, the derivative of x or x dot of 0 is also 0. So that is all valid in time t is 0. And then the next assumption is that we have force in a certain form. So we looked at some signal types and input types. If you remember from the lecture, we looked at what was it called? Yeah, impulse, or wider version, a pulse. We also looked at exponential functions or data, and also we looked at ramp. Another type that we looked was called the step. So here let's work with a step, meaning that when we are looking at time, let's call this point t1. From 0 to t1 there is no input, so this force from this point to this point during this time is 0. And then suddenly, all of a sudden, at point t1 we have this constant force pass to our system. Okay, again, if I put that system black box on top of the system and I look at my input and I expect the output, so this input is the force F and the output is the displacement or X. So this force, the F of t, is 0 from the t is 0 to t1, or you can say less than t1. Less than t1. And then if we assume that this value here is unit 1, we can say that f of t1 is equal to 1. That defines step input. Now we want to plug this into the equation that we had based on Laplace Transform. So from Laplace Transform, sorry for my handwriting, we have x of s is equal to f of s over m square s2 ms square plus cs plus k. Now what we can do is we can replace k, c and m with the numerical value that are given to us from the system. Let's have some examples. Let's say k is 10, m is 5, and c is 20. We don't care about the units, but they have their own parameters and units. So if I use these constants into my formula and also have these values incorporated into my formula, I'm going to have this form. X of s will be equal to 1 over s divided by m is 5 s2 plus 20, that's the c, s plus k is 10. If you're wondering where that 1 over s come from, I have to refer to the table. If you give me a second, I get the table from one of my notes. Okay, so here is the table. If I have f of t equal to 1, the Laplace transform becomes 1 over s. So Laplace transform of f of t1, which will be Laplace transform of 1, will be 1 over s. That's what happened here. Right? Now, let's continue on that. The s can go down, and then I can have x of s equal to 1 over s multiplied in 5 s2 plus 20s plus 10. Now, if you remember from previous videos, we want to see what conditions are going to turn this part of this fraction to 0. So I'm going to put s multiply in 5s2 plus 20s plus 10 equal to 0. So right away, one thing that comes out of that is that s is 0. That's one of the options, right? Now another option would be that 5s2 plus 20s plus 10 is 0. We want to simplify that. Let's divide everything by 5. That brings us to s2 plus 4s plus 2 is equal to, that part will be 0 divided by 5, which is 0. Now we can do one more step, which is adding a value in a way that I can turn the quadratic part into simplified version, and that gives me the possible values of s. Alright, so think about it for a second before I write it down, how that is possible. Alright, so I'm going to move this number 2 to the other side. I'm going to move that there. It gets negative. And now I want to make that in a way that looks like simplified version, so I can calculate the s, and I have only s, not s squared. So I'm going to plus both sides, add 4 to the both sides, so it will be s2 plus 4s plus 4. The other side will be minus 2 plus 4, which is equal to 2. Now this looks much nicer because we do know that we can be written as s plus 2 square, and the other side is 2. If this replacement is not clear, I'm just going to explain it here. S plus 2 square can be written as s plus 2 multiplied in s plus 2. So I'm just going to multiply this with this, multiply with this, this, and that. So it will be s2 plus 2s plus 2s plus 2 multiplying 2, which is 4. s2 plus 2s plus 2s is 4s, and then here we go. Look, this is exactly what we had here. That's how I wrote it this way. Now, this is nice because then I can say that, okay, s plus 2, if I square root both sides of the equation, can have positive or negative result of square root of 2. Why is that so? Because we know that there is a possibility that the result of that is negative, and as a result of squaring the whole thing becomes positive. So that's one of the possibilities. Now we can use calculator to come up with the result of minus the square root of 2. I give you a second to calculate that yourself before I write it down. So I have two paths here. One will be my s will be equal to plus the square root of 2. The 2 will go the other side, minus 2. And what's that value? That is 1 point, I'm sorry, my page is a little bit down. That is 1.414 minus 2. That will be s, one possible value for that. Yep. If I take only one digit after decimal point, that s can be how much? Minus, because 2 is bigger, 0.6 approximately. That's one option. Another option is when s is minus square root of 2 minus 2. So the result of that will be minus 1.414 minus 2. If I take into consideration only one digit after decimal point, that can give us approximate value of minus 3.4. So what are these values that we calculate?